So in this example, what you guys notice in this example is that I do not have a variable that's solved by itself. In the first two examples, it was nice. You have a variable that says it's equal to this. So you say, oh, whatever that one variable is equal to, that's what I'm just going to plug into the other equation. But there are going to be more than likely equations that are going to look like this, where it's not solved by itself. So what I like to do to determine what I should solve for, I like to look at all of my coefficients and determine which one of them has 1 or -1 as a coefficient, which obviously, though x is the only one that has a 1 as its coefficient, right? Because it's just written as x, which we know can be written as a 1 as a coefficient. So once we identify that we have 1 or -1, we can still do substitution. What we simply need to do is now just solve for x. All right? Ladies and gentlemen, you could solve for each one of these variables if you wanted to. But just by choosing the variable that has a coefficient of 1, look how easy it is to solve. Right? All I'm simply doing is just subtracting the 3y, and it's solved for x. Now, all I did was I rewrote this equation. It's the same equation. It's just rewritten, but now it's rewritten as x being by itself. So now I know the value of x is -3y plus 2. That's what I'm now going to plug in to this equation to go ahead and finish off my substitution. So I have 3 times -3y plus 2 plus 9y equals 6. So does everybody see like the difference that I had for this equation compared to another one? There's only one extra step, and that was solving for x. But once I solve for x, now I just follow through like I've done before. So I'll apply distributive property. So I get -9y plus 6 equals 9y plus 9y equals 6. Now in this case, my variables cancel out as well. But now I'm left with 6 equals 6. And 6 equals 6, Stephen? Yes. And is 6 always equals 6? Yes. So that is true for every value of x. It doesn't matter what the value of x is. It's always going to be true. And since it's always going to be true, that means it's infinite many solutions, meaning if you were to graph it, it would contain the exact same line. OK? So I'm going to do things a little bit different for you guys.